Hi, so in this video we're going to see about context managers, and the first example of context managers in Python that you would have seen is opening a file and reading the file, and that's exactly what I have here. In fact, let's go and print out this file cat data slash temp.csv. That's a bash command that you can run inside the IPython notebook, and here you can see I have a bunch of stuff. And here I'm opening the file, reading the file, and printing the first line alone. I can also do read all, I think just read to do the same thing as cat, right? This is very simple Python thing, and this is a very common pattern you would have seen. And in here, if I check if the file was closed properly, it was. And this is a very common pattern. If you're doing this, you're doing it right. But you can also do it in a different way. For example, here I'm opening the file very similar to the way here, and this R is for read. If you were to write, you would do it as a W, but let's keep it at R. Here it's a default parameter, so I have not mentioned it, so you can also remove it. Now, when I'm reading, I'm also creating a zero division error, and then I'm explicitly closing the file. So in this way, before the program could reach close, in line number 2, there is an error. It's saying you cannot do a division on integer and a string. Probably this is a string, and then you're trying to divide it by integer. But we are not interested in that. I'm mostly interested in to see whether the file is closed. It was not. So what you have to do is you have to explicitly close the file in case of an error, and then you have to check if the file is properly closed. Now it's closed, right? So you have to explicitly do that in case of an error. And in Python, we know that to handle error, we use something called as exception handling. Now, exception handling gives us exactly that. So in this case, I'm writing that opening logic inside a try block, and I'm instigating that error. And anytime an exception happens, I'm capturing that. And this finally block helps me close the file irrespective of whether an exception has occurred or not. So if I run this, there is an exception that has occurred, but if I were to see if the file was properly closed, it was. I don't have to explicitly go and close it. But instead of going through this whole trouble of using a try, except, and finally block, this is the same mechanism that's being provided by a context manager. Here, there is an IO error that happened, but if I check if the file was closed properly, it was very similar to using a finally block. And that's the power of using context managers. Now, all of this has nothing to do with context managers. We already saw that this is what context manager is. Every time you use a with keyword and you write a function call and assign it to a variable, and then using that variable you do some operations. But the whole point of understanding context managers is why does this work or how does this work? That's what we are trying to do. And if at all you write your own function, instead of open, you're writing your own function called open file, how would that work? Will it even work? First of all, open file is not even a function. And we know that this is a function. So let's go ahead and maybe define a function called open file. And to this, we will pass a file path. And this is not going to do anything. Maybe because we have to assign a variable, let's do a variable that is a function that returns a string, because you might need a function, I don't know exactly. So I'm just going to return this x, right? And now I'm writing my own context manager open file. Now it's saying function object does not support the context manager protocol. That means you can write your own context managers. It's just that that is not the pattern. Like it's not as simple as writing a function and calling it a context manager. So what should you actually do if you were to write your own context managers? And that's what we will see now. Before we go and understand the pattern of how context managers works, we have two patterns, the functional and the class based. We will go through both of them, but before we do that, we have to take a small detour. In functional context managers, we use something called as yield. Let's understand that a little bit. Here I have a function called random function, and it has two print methods, do something and do something else. Now, anytime in a function you use a yield parameter or use a yield statement, what happens is that function will return a generator. What do I mean by that? If I put a type of x, if I print out what is the type of x, you will see that it's of type generator. And every time it's a generator, you can call this function called next on it and make it do something. And what does that something do? So it will actually go and start executing that function only after you call next on it. Unlike other functions where if there is no yield here, what will happen is the function would have been called and things would have been printed. Um, yeah, because you have to rerun this and then the function would have been called and the responses would have been printed. But because you have yield here, the output suddenly becomes a generator object, and because it's a generator object, you can call next on it to make it do something, and then you call it again, it will do something else this way, and it will exit that function with a stop iteration. Now this is the mechanism of a yield keyword, and where do we use it is anytime you want to do an operation, pause that operation, do something else, and then come back to where it was left off. If I were to put it in context manager's way, I want to, let's say, open a file, return the file object, do whatever you want with the file object, and then at the end, no matter whatever happens, um, I would close the file. So that is the pattern that we're going to follow in the context manager. If I were to do this again, you won't see the print statements, but you will still see that it's still a generator. You can call next on it and you can call next on it until the yield, like the function stops. Just having a yield keyword will not make it a context manager. Why is that? Let's find out. And this is again, if you were to use it as a context manager, you have to use with open file, and to this there is no parameter as f, and with f we can do whatever, and which is going to print the f. Okay. Now, if I were to do this, you will get an error saying again generator object does not support context manager protocol. We are so close. First, we tried it with a normal function. Now we are trying it with a generator. We are so close, but it's still not a context manager protocol. So how do you make a function a context manager? There is something called as context lib in Python standard library that has a decorator called context manager. The moment you decorate that function and you write this whole try except finally block inside it along with the yield. So here what happens is, here is my try block. I will open the file and yield the file object, and finally I'll close it. Now this is exactly how the open file of our Python standard library also works. Now I can add it to a with block, and then it would raise an error, of course, but the file would have been closed. If I were to not do this finally, or if I were to not do this f.close, what will happen is the file would not be closed. So this is what makes a normal function a context manager. Just by adding that decorator, it does it. Why is just adding that decorator makes it a context manager? What is it doing? That is what the whole part of depths of Python, right? We have to go one step further. We cannot just leave it here. So to figure out that, we are going to use our help function and see what it actually does. So here is a very nice documentation. It says this is how you use it, this is how you make it as a context manager, and then this doesn't really tell you about the internals, but it does give you a very good understanding of what context lib is. To figure that out, what can we do is, let's do a dir on the context lib, see if we get something. We have to import it explicitly, import context lib, and then there. Now in here, all of that is, there is a context manager, and there is DQ and a bunch of things. These are all, again, other standard libraries. The ones that are interesting to me are these abstract classes, and then these underscore classes, which are like here, generator, context manager. So this is what I'm most interested in, because abstract will give you just the stubs, like what are the function definitions, but these might have some idea. And async, we are not talking about async at all in this course. So between these two, this is a base class and this is a normal class. So we're going to go and find out what this class actually is. Okay, that is a help, and this is the class that we are most interested in. What makes a normal class like this a context library or context manager is that these two methods, enter method and an exit method. Any normal class cannot become a context manager unless it has enter method and an exit method. And that's very similar to your yield, because you're entering, giving off the control, and then you're exiting. So let's go to the class-based context manager. Here I have an open file class with an enter method and an exit method. Enter method reads the file, returns the file object. Exit method captures the exception and closes the file. And this is the similar pattern that we'll use even if you're doing a database connection, even if you're persisting a database connection. So this is the class, and the exit needs to be this exact replica. It has to be an exception type, exception value, and then the traceback, which is what we are using here as well. And here you open the file, you close the file. Even if you cause an error, let's say 0 by F2, which is what we will be doing, and you see closed, it would have been closed. But if at all I don't do this and I still run this, it would have not been closed. So if you have a use case where you have to use a external resource, but you have to ensure that something happens even if there is an error, this is a pattern that you would use. And that's what context managers is all about. Functional route is much more easier and straightforward, whereas class route is much more cleaner. Whatever you want to do is up to you for your use case.